You might want a calculator out today just for converting from degrees to radians, radians to degrees, adding and subtracting. That's okay. Thank you. This goes to the other Bennett. I'm sorry. This goes to the art teacher. She sounded like this really nice. She has the same last name. Happens a lot. I didn't think I ordered anything. All right, so if you notice that they form a full circle, how many degrees are in a full circle? 360. So the hint or the shortcut to solve these is your add or subtract 360 to find the coterminal angle. So if it's a positive angle, you're going to subtract 360. If it's a negative angle, you'll add 360. Now sometimes you'll have to add or subtract 360 multiple times to get it to be something that doesn't spiral around. Okay, so that it's somewhere between 0 and 360, but sometimes you have to do it multiple times.
We draw it.
I would draw this picture. Yeah. I would draw this if I were you. This helps you the most to understand what they are. So one of them goes this way, the other one goes this way. Together, they create 360 degrees. I really don't feel that bad. I just sound bad. Okay. So we're going to find the coterminal angle, and then we're also going to find the exact value using our chart. So if you don't have your formula sheet out, go ahead and get it out. Obviously, I have mine up here, but good luck seeing it, right? Well, yeah, you sit in the front row. Okay, so the reason we're going to use coterminal angles is that 390 is not in my chart. So if I want to find the sine of 390 without a calculator, I can't do it using my chart. Okay, so we're going to take away one whole revolution and we're going to find out what angle is. We also don't have negative angles on our chart, so that's another reason. So since this is a positive angle, we are going to subtract 360 to get that the coterminal angle would be 30 degrees. 30 degrees is in my chart. I go to 30. I look at the sine. The sine is 1/2. So like both of those are your answers because they asked you to find the coterminal angle and then use that angle to find the exact value of the expression. Now for letter B, if you could change this to negative 510, otherwise it doesn't go on the chart. So change that, get rid of the 500, negative 500, negative 510. All right, now this one, since it starts out negative, it's going around multiple times. So to get it back to become positive, we're going to add 360 this time. If you subtract 360, you're just going to get further and further into the negative. Now we may have to do this multiple times. We'll see. So we have negative 510 plus 360 gets me negative 150. Now in our chart, we don't have negative angles. Okay. So in order to use the chart, we have to add 360 again. And we'll get our positive answer, which should fall in our chart, 210. That's the coterminal angle. So it's going to have the same value as the original one. So the tangent of 210, here's 210, here's my tangent, square root of 3 over 3. Did you say this is really easy?
No, you just add it to
yeah. And you don't want to keep adding it so that it gets bigger than this, but yeah, you might have to subtract it multiple times until you find a number that's in your chart. Okay. Now, most of you don't like radians. Okay. And I should tell you, do you remember, we know 360 degrees, do you remember how many radians are in a whole revolution? 2 pi. Okay, so you could also add or subtract 2 pi multiple times, which is really not that bad, but some of you hate pi's and you hate fractions, and therefore you will convert this to degrees most likely, and then do 360. If you were doing this using pi, you would actually subtract 2 pi, and you might not want to take notes on this because most of you won't like this. You would have to make a common denominator, which would be 2, so we'd have to multiply by 4 to get 8 pi fourths. And then we can subtract. 11 minus 8 gets me. Wait. 2. I'm sorry. And this should be 4. I didn't even take cold medicine yet. Okay. So we should have multiplied by 2 to get 4 pi over 2. There we go. And then 11 minus 4 gets me 7 pi halves, which 7 pi halves is also not in my chart. So then I would have to do this process again. So subtract 4 pi halves, and we would get 3 pi halves, which is in my chart somewhere. Okay, then you would just look at the cosine of that, which is 0. Okay, now for those of you not feeling it, not liking it, you convert it to degrees. How do we convert 11 pi over 2 to degrees? Times 180 over pi. Remember that the pi's would divide out, so we can just multiply 11 times 180 and divide by 2. We'll get 990, okay? And then from there, we would have to subtract 360 probably twice, I'm thinking, to get it to be a number that's in my chart. I subtract 360 once, I get 630. Subtract 360 again, I get 270, and 270 is in my chart. So you stop as soon as you get a number that's in your chart. You'll notice you have no negative numbers. Okay, and then we wanted to find, that was 270, right? This one says the cosine of 270, which is 0. Okay, why don't you guys try the next 3? Actually, we'll do one of these together because we have to do the reciprocal. Okay. Do we want to convert this to degrees? Do you like that better? Okay, we'll multiply by 180 over pi. Again, the pi's always divide out. That's the whole point of this. So negative 9 times 180 divided by 4. So that's secant of negative 405. Am I going to add 360 or subtract 360 to find the coterminal angle? Add. I have a negative angle. I need to make it into a positive angle. So I'll add 360 one time. And I'm still at a negative angle. I don't have negative angles in my chart, so I have to add 360 again. And I'll get 315. Now the problem comes into play that the secant is not in my chart. So here's 315, but I don't have a secant. How do I find the secant? Go to the cosine and do what with the cosine? Take the reciprocal of the cosine. So this would become 2 over the square root of 2. Because the cosine was square root of 2 over 2. Then you have to rationalize. So we'll multiply by the square root of 2. We'll get 2 square roots of 2 over the square root of 4, which is 2. And then some of you have just been not simplifying all the way down. So if you have 2 outside numbers, you can reduce them or divide them out. And our final answer here should be just the square root of 2. But 315 was the coterminal. All right, you guys try the E and F. Over 1, which is still not 1. How about the last one? You just subtract quite a few times here.
Cosine of 1485.
Cosine of what?
1485. 1485. And then it comes up to be 45.
Yes, subtract 360 1, 2, 3, 4 times until you get an angle that is positive and in our chart. And that's why I suggest just using the calculator, so you can just hit enter and be done. Even if you were doing it in radians, you'd still have to subtract 2 pi that many times as well. And then our final answer here should have been 45 cosine squared of 2 over 2. All right, now we're going to switch gears on the back, and we're going to look at not coterminal angles, but reference angles. Okay, so there's 2 different types. Coterminals are those that share a terminal side, terminal side. The reference angles, these are the ones that we actually used yesterday. They're the ones that we actually create a right triangle with the terminal side, with the origin and the x-axis. So the formal definition says that it's an acute angle formed by the terminal side of theta, and let me just make this a little shorter for you. And let's just say and the x-axis instead of saying positive and negative x. So it's formed by the terminal side and the x-axis. So it's going to create a right triangle just like we did yesterday, touching the origin and touching the x-axis, and it's going to be that angle. Now what makes this more difficult is you're not just always adding or subtracting 360. You actually have to think about where the angle would fall and what you would be subtracting based on what quadrant it falls in. So you have a couple options. You can memorize the formulas I'm about to show you, which most of you won't memorize because there's 4 of them, and you might mix them up. I suggest drawing the picture and then logically thinking it through, which I'll show you in a second. So first you have to determine which quadrant it falls in. And I would do that by sketching a picture. And just real quickly, an acute angle, what does that mean? Less than 90 degrees, good. Greater than 0, less than 90. A small angle, yes. It's cute. Okay. If the angle is in quadrant 1, the reference angle is the angle itself. Because this angle would be acute, right? Because it's less than 90. So if it's in quadrant 1, the angle, reference angle is the angle itself. So 45 is 45. 60 is 60. 75 is 75. If the angle falls in quadrant 2, so let's say, I'm probably going to steal my thunder here, so let's not do an example. Let's say that this was 160 degrees. Okay. The reference angle has to be this angle. How many degrees would this angle have to be?
110. Doesn't have to get to 2.
It will be 20. Remember, how many degrees are in a straight line? 180. So if it's in quadrant 2, to find out what this angle is, you're going to take 180 and you're going to subtract the angle. 180 minus 160 gets me 20.
This part wasn't on the class, the 2 steps. For some reason that wasn't. That was the only part.
I have like a drawing.
Yeah, that was.
Yeah. Every year I try to change it to make it easier to understand. This trig is confusing. All right, now quadrant 3, and let's do it using numbers. So if the angle were here, let's say it's 200 degrees. Okay, so if the angle goes all the way down into quadrant 3, the reference angle would be this one. Close. It'll just be 20. Yeah. So for this one, you're actually going to, if the whole thing is 200, you're going to subtract 180 to get rid of this part to see how much you're left with. So 200 minus 180 will get me 20 degrees. So this one is A minus 100 instead of 100 minus A. It will always be positive, yes. The reference angle will always be positive. And that's actually, yeah, acute is greater than 0, less than 90, so that's but you might want to jot that down. That's a good point, Evan. Oh, I have that up there
She's saying yes for
on my notes.
Yeah.
I see. Yes, yes, you may. And then if it's in quadrant 4, you would have to create a right angle here. So you'd have to actually do what with it? 360 minus A. So you're going to take the whole circle, subtract the angle to see what you're left with, that little sliver.
I think I could do it now.
So all of them are different. That's the problem. On the front, you were always adding and subtracting 360. It's easy. You just kept doing the same thing over and over again. For these ones, you have to think about it. So I suggest drawing a picture.
Why can't I get like a formula? Can I have one?
So I would sketch it. 150 degrees would be right here somewhere, right? 150 degrees. I'm just sketching my picture. We did this earlier in the year.
Like, I can do that.
Okay. The reference angle has to be the acute angle formed by the x-axis and the terminal side. So I'm going to create one. It'll be right here. That's the angle I'm looking for. And then you can kind of use some of your logic that this has 180 degrees in it, a straight line. So 180 minus 150 tells me that the reference angle has to be 30. Now, if you wanted to, you could say it lies in quadrant 2. The formula for quadrant 2 is 180 minus A, so you plug into that formula, but you have to memorize the four formulas.
So it's just logic.
It is, for me, it's logic, I think, but. Now, this one is a negative angle, which is a little bit different. How do we draw a negative angle? We go down. Okay, so the initial side's still here, but the terminal side would be here. And then there's 2 ways that you can get the answer for this one. Remember that it has to be acute. It has to be an angle that's formed with the x-axis. So you can either just make it a positive 45, which is the easy way to think of it, or you can follow the formula for quadrant 4, which was 360 minus a negative 45, which would make you add 45, which would get us 405. Now, by the definition of a reference angle, it has to be acute. So you'd have to use what we did on the front, the coterminal angles, to subtract 360. But if it's a negative number and it's acute, you can just make it positive because that's what it's going to end up being. Okay, now our radians. You guys want to convert this? You can also graph it the way that we've done, but what do we get?
4 to 5.
Okay. So if it's 405, before you even sketch the graph, you might want to use what we learned on the front, the coterminal, to get rid of one full revolution. So we'll subtract 360, and we'll get 45, which that should tell you that's the answer, but if you need to sketch it to see it, 45 degrees is right here. It is acute, and it is touching the x-axis, so that's your answer. Ooh, but it was in radians. We should go back to radians, so change that back to pi fourths. So this is on your formula sheet if you just look on the back. 45 pi over 4, you don't even have to convert, you could just look at it. Kind of. But if it's in radians, you technically should give an answer in radians. Okay, we have another one that's negative. If you want, you could just graph it using radians, which is what I would do. But negative 5 pi over 6. So the angle we're looking for would be right here. has to be positive.
So that's like
It's negative 150. So you can think of this as being like, to get to negative 180, what would I have to have here? This would be 30, which is pi over 6. Which again, sometimes it's easier to leave it in radians and see that you're missing. What am I missing here to get to the x-axis? I'm missing pi 6, 1/6 of pi. See if you can try the last two.